In the video you're about to watch, I'm going to be showing you a number of things. First of all, if you like the way I do Le Chatelier problems and the little form that I use, you can get it by clicking here if you have notebook software, or if you're just watching this on the video, you can just copy this and that will give you the address directly into my website where you can pick this up. Alternatively, you could go to my website, www.mrwiggersci.com, MRWIGGERSCI.com, as you see here, /Kim, and then you can go to my tutorials, and tutorials are under Learning Center. So if you go to Learning Center and you click tutorials, and you go to chapter 18, it will be the last tutorial in chapter 18. Or you can just copy this. Anyway, another thing is I'm going to explain what this guy is all about. So what the delta H means and how to position the heat in a balanced equation. A page to show you how Le Chatelier equilibrium shift positions are going to work with my little form. The do now for today, and then a homework problem on page 574. And I just added that little page number in there if you have our textbook, and the problem number. And then the homework problem that we're doing from tonight, or the homework problem that we're doing from last night, is number 13 on page 574, A, B, and C. So hold on, here we go. This first little page right here that I'm showing you talks about the delta H. Delta H being negative means that it will be an exothermic reaction. And exothermic reactions, the heat is going to be on the right side as it says down here. Delta H being positive means that the reaction is endothermic and the heat will be on the left side of the equation here. Excuse me. So if a system loses kilojoules or loses energy, because kilojoules is a measure of energy, you will feel the temperature going up. And that is because this guy is exothermic. And exothermic produces heat. And so the system itself is losing energy. So think of kilojoules as heat being lost or gained from the system, which is your equilibrium mixture. Now, if the delta H is positive, that means you have an endothermic reaction and heat will be on the left. So this one, you might want to write this whole thing down and it will help you stay oriented so far as how to do the problems. Next, this sheet, I would recommend you copy it down. And by copying it down, what you're going to do for yourself is when you see that Le Chatelier wants to increase something, you'll know that he has to shift the reaction to the same side that that something is on. When Le Chatelier wants to decrease something, he goes to the opposite side. Now this is assuming that we're working with concentrations. If we're working with pressures, Le Chat is going to have to work with the number of moles. The side with more moles, and we count that by, or we figure that by taking all of the reactants or products, and we count up reactants and products, right? So we're going to count up first of all the reactants, and then we'll count up the products' coefficients. That's the number that we use for balancing an equation. If there is no coefficient, the number is 1. And for this little exercise, anything that has a state that is solid, solids do not get any effect, or do not have any effect on equilibria. So we don't count those when we're counting the moles. So when we want more pressure, and what's this pressure happening by? How do we stress the system? By increasing or decreasing the size of the vessel. And when we increase the vessel, the relationship of the pressure to the size is going to be inverse. So a bigger size makes a smaller a bigger size of the vessel will make a smaller pressure. And a smaller size for a vessel, as we shove the piston down or squeeze the balloon, is going to make more pressure. So that's what we call inverse. So Le Chat, when he wants more pressure, is going to go to the side of the equation. He'll make the shift to the side with more moles, and when he wants less pressure, he'll go to the side with fewer moles. Now, temperature works just like concentration, only the thing that we're looking at is the heat. When heat is on the left, it's endothermic. When heat's on the right, it's exothermic. And depending on which side the heat is on, we'll go to the left or the right depending on whether the heat is left or right, if it's same. If the heat's on the left and we're trying to reduce the temperature, we will go to the opposite side of heat. So that's how we use this little sheet to do our equilibrium shifts. And next comes that do now problem that we did in class today. And basically what I did, we set up as a responder quiz the questions. We answered them in class by having a responder quiz with the smartboard, and then I had the students come up and write these guys in. So I'm going to do the part that the students wrote in to show you how to use this little sheet that I gave you the document or the address for on my website. So the problem is right here, so it's very easy to follow, and let's go ahead and solve the problem. We are going to be working with this balanced equation, and we're going to start with letter A, and in this one the stressor is going to be water, and that stressor is going to be added. So what's happening is we're going to put water here as the stress, and the stress is going to be water increasing. We're going to increase the concentration. So in that last little thing I showed you, you want to refer back to that to see what that means. Now, Le Chat is like a naughty teenager. He wants to do the opposite of whatever you want to do. So what he's going to do is he's going to try and decrease the amount of water. Now you added water from the outside, but he can't add anything, or he can't add anything to the chamber, and he cannot add or take away anything by taking it out of the chamber. So what he has to do is he has to simply manipulate the reaction. And with hydrogen, or with water, I'm sorry, being on the right-hand side here, that's going to identify the kind of the point of contact or the point of reference for what Le Chat is doing. Now Le Chat in this case, to reduce the amount of water, which is what this down arrow means, okay? Here we increase the water, and Le Chat wants to decrease the amount of water. To decrease the amount of water in concentration, or in solutions, what he has to do is move the reaction to the opposite side. And it's the opposite side from our species that was the stressor. So since water is on the right side for Le Chat, the shift would be to the left, the opposite side. So he's going to do a left shift, and that will increase the water, or decrease the water, because when we go opposite of whatever side the stressor's on, that will give us the shift that will decrease the amount of that stressor. All right, and let's go on now to the second question. Think for a moment what the stressor is, and stop the tape if you have to, but think about it for just a second. Now, I'm going to identify the stressor as carbon monoxide. Now we have carbon dioxide over here, but the one that we wanted was carbon monoxide. And so for carbon monoxide, the stressor is CO that we put up here, and we are removing. Removing means that it actually decreases. So Le Chat, like any naughty teenager, will try to make it go up. That's what he wants to do. Now in concentration types problems, increasing means that we have to go to the side of the reaction which is the same side as the side that the stressor is on. In this case, carbon monoxide is on the right side. And because carbon monoxide is on the right side, same now has the meaning of right. And so the shift will be to the right. Okay, next problem. This is adding hydrogen. So we're adding hydrogen, and now let's identify it in the equation as to where it is. Here it is in the balanced equation. And so let's go ahead and put in hydrogen, because hydrogen is our stressor. And we're adding, so that increases the concentration. And Le Chat is going to want to reduce the concentration. And again, for reduce, we have to go opposite. Now, opposite for this problem is in relationship to where hydrogen is. And as we see, hydrogen here is on the left side. So opposite of left is right, and that is the shift that will show us what Le Chat is going to do when we stress it by adding more hydrogen. And then our final problem looks like an adding problem, but it's not. What's being added? Here, this is the problem we're on now. What's being added? We're adding something that to the system that absorbs carbon dioxide. So if it absorbs carbon dioxide, that means it's like removing it. Now it doesn't really remove it, it just makes the reaction go in such a way that it will use it up. So carbon dioxide, that's our baby, and the thing that we want to do is reduce it. So carbon dioxide, the concentration will go down. And Le Chat, meaning his naughty little teenager self, is going to take the CO2 and he wants it to go back up. Now to increase the amount of CO2, we have to go to the same side as the CO2 is on. Since CO2 is on the left, same now has the meaning of left, and that will be the shift that Le Chat wants to do, or will do, to try to restore CO2 to its original concentration. And as we know, he never makes it. He never gets it fully restored, but he gets it partially there. And this is what we did as a do now today. Okay, the problem that I call one of the most difficult types of Le Chatelier problems is this dude. It doesn't get any more difficult than this. So here is your sample problem, or a sample equation of what we're going to deal with here. We are dealing with C2H2, water, and acetic acid, CH3CHO. So for acetic acid, we want to try to and heat. We've got heat, and we weren't given heat where it was. We were given the heat in these terms right here, which is why I did that first little sheet that is in this video. When delta H is negative, that means we have an exothermic reaction. All exothermic reactions have heat that acts kind of like a product in these Le Chatelier problems, but we'd write it as heat, and it isn't in the balanced equation. We don't balance the equation with heat, but heat is treated as a product for this particular equation because it's exothermic. And we know it's exothermic again because delta H is negative. So here's how it's actually written in our textbook, and you can see that delta H is a negative number, and because it is negative, that means that we are going to put heat here on the right side, because that is an exothermic reaction, and with exothermic reactions, heat is always on the right. Now we're going to look at increasing in the amount of the product. There's only one product, and so this little dude right here you see on the right side of the equation, on the same side as the heat, and the C2H2 over here and the H2O here. So I'll be manipulating this equation in the problem. Okay, now you can see the equation itself on the same page that I'm on, and why the formula or the equation came out the way it did. So we're going to, first of all, we want to, in order to solve this problem, the first thing we want to do is see what Le Chat does. Okay, why do we want to do that? In the problem it's stating, in the following equilibrium, would you raise or lower the temperature? So let's do a little investigative work and find out what Le Chat will do when we raise or lower the temperature. And now, as you can see here, when we stress the system with raising the temperature, Le Chat wants to decrease the temperature. And for Le Chat to decrease the temperature, he has to move to the opposite side as the heat. And let's go back and look at that in this little guy with temperature. See, if Le Chat wants to increase the temperature, he's got to go to the same side. If he wants to reduce the temperature, he's got to go to the opposite side from where the heat is. I slowed down there because this takes a little bit of thinking and getting this into our heads. So the opposite side, whoops, let's move that back. Okay, the opposite side from the heat, since heat is on the right, will be a left, and the shift is to the left. So that's the temperature going up. That's the stress. See, that's with stress going up. And now, the want to is what Le Chat wants to do, of course, always the opposite of what we do. Okay, let's do it the other way now. Temperature going down, what's that going to do? Well, Le Chat wants to raise it. And to raise it, he's got to shift to the same side as the heat is on. And heat here is on the right, so the shift is to the right. Now we got our Le Chat dude nailed. We know what he will do when we need him to do it. So now what we do is use this set of data, this left-right, and this stress, up or down, to be able to interpret what we need to do, whether we're going to increase the temp or lower the temp, depending on what the problem is asking. So the problem is asking us to get an increase in heat. What do we do to, I'm sorry, not heat, but increase in this acetic acid, CH3CHO. So to get that, what we want to do is put Le Chat as the stuff that he wants to do. Okay, your thinking has to become Le Chat thinking. Okay, you're now thinking like Le Chat. And whatever we put in this column to get the shift that we want, or that Le Chat wants, that's going to give us, whether we're, see, like for the left-hand shift, that's going to give us the information that we need to increase the temperature. For our right-hand shift, that gives us the information that we need to decrease the temperature so that Le Chat will increase it. And we know that to do those two things, the shifts will have to match. So when I want water to be increased, I'm going to think like Le Chat in the green here, and I'm going to increase the water. And to increase water, I got to go to the same side that the water is on. Now let me turn this arrow upside down, and I'll point to where water is. See, here he is on the left-hand side. So with water on the left side, okay, the same means left. So I want a left shift. How am I going to get a left shift? Temperature up. And I've just answered this question. Now, how am I going to get C2H2 to go down? Well, to do that, we have to go to the opposite side as the C2H2. Now you see, everything is from the perspective of these guys and not from the heat. When I was doing the Le Chat stuff, I was doing everything from the heat perspective. So down here, when I say C2H2 down, this guy's on the left side, and down always means opposite to Le Chat, and opposite of the C2H2 being on the left would be a right shift. So if I want Le Chat to do a right shift, I'm going to cool the reaction mixture. Isn't that neat? Okay, here's the last guy, the CH3CHO. Okay, we want Le Chat to make this guy go up. And when Le Chat thinks that he needs to rise, he's got to go to the same side that the stuff is on that he wants to increase. So this guy is on the right, and same on this line is right because our reference point is CH3CHO. Here we had a right shift because our reference point was this guy who's on the left, and we want to go opposite to the left side, which winds up giving us the same shift. So for both of these, a right shift will be caused by making a decrease in temperature as the stress. And we have just solved the problems. I have a little summary down below that you might want to look at. If you find this confusing, just forget it, but that's a summary of what we just did. So I hope you get a little better input here as to how to work these Le Chatelier problems and why I did this in two pieces. This had to be done to find out what I need to do as a stressor to make Le Chat do what I want him to do when we need to get more of this. So more of this happens with a right shift, and I go back here to see that a right shift is caused by my doing a temperature down shift. It's making sense, isn't it? Yes. I have a few students in the class who are getting engaged here. They're seeing what's really happening here. This guy, when I want him to go down, I notice that the opposite has to happen. That's a right, and the right shift tells me I have to lower the temperature again. Temperature's got to go down to get Le Chat to make a right shift, and when he makes a right shift, what does that do to the amount of this stuff? He's on the left, and a right shift reduces him. Okay? And the left shift happens here with the temperature increase when I want to make more water. Okay? Water is on the left, and the same side that water's on is the left side, and a left-hand shift is caused by a temperature increase. So as the temperature goes, when I stress it with the upward temperature, Le Chat will shift left, and that will help me to make more water. So Le Chat becomes my friend instead of my enemy. And I think I've done it here. This looks like a good recording. I hope you enjoy it. Save it.